Module 2, Lesson 4, Summarizing Deviations from the Mean. Here, our instructional outcome will be to calculate the deviation from the mean and explain its meaning. So, in exercises 1 through 3, we have a consumers organization that is planning a study of various brands of batteries that are available. As part of its planning, it measures lifetime, or how long a battery can be used before it's replaced, for each of the 6 batteries in brand A and for 8 batteries of brand B. So in this anticipatory set, we asked the students to think about 3 questions. One of them says, does one brand of battery tend to last longer, or are they roughly the same? What calculations could you do in order to compare the batteries' lives of each of those particular batteries? And so in looking at that, the students kind of think about it and look at it and come up with some ideas as to what that may be. And so does one brand of battery tend to last longer? Well, students may tend to argue yes, because brand B has one that lasts 100 and over 120, but then another student might argue, yeah, but one only lasted less than 75. And then another student may say, well, brand A didn't last a long time, but they also didn't die real short either. They were kind of concise in their information and thought in those particular pieces. And so those are all things that students could think and talk about what that is. What calculation could I do in order to compare the battery lives of the 2 brands? Well, the students could find and say, well, let's just take and find the mean or the average of each one. And so the students took and added up approximately where these are. And again, these are approximate. We might note that the mean for this one is approximately 101 hours for this one versus the brand B, which is in red. The mean or the average would be about 100.5 given those particular values. In question 2, do the battery lives tend to differ more from one battery to another battery? And so again, the students might say, well, the lives tend to vary a lot more with brand B than they do with brand A, and that's that conciseness of brand A, that while it's spread out a lot less as compared to brand B, you see one all the way down below 75 and one all the way up above 120. And so that tends to be a very big differentiation of different battery lives. And so in number 3, would you prefer a battery brand that has battery lives that do not vary as much from battery to battery? Why or why not? And so again, students would talk, and most students will come to the conclusion that they would probably prefer a battery with small variability in lifespan, because the batteries would be more consistent and more predictable from time to time. Meaning if you put a battery in there, you pretty much know how long that battery is going to last. Then if you buy a brand such as B, where you don't know how long that battery is going to last because there's too much variability in its particular lifespan. So in exercise 4, we want the students to take this table for brand A, the different life hours for each of these 6 batteries, where we have the 83, the 94, the 96, the 106, the 113, and the 114. They want us to find the deviation from the mean. So the way that we find the deviation from the mean is first take the mean, which we stated on the other slide. The mean for this one was 101. So if I wanted to find the deviation from the mean, what I'm going to do is take each of these numbers and I'm going to subtract 101 from each of these values as I'm writing here. So when I subtract 101 from each of these particular pieces, I get a negative 18, a negative 7, a negative 5, a positive 5, a positive 12, and a positive 13. The positives and negatives do tell a story in terms of this deviation. If it turns up negative, it means it was below the average. So in this band, we could say the first 3 batteries lasted less than the average, whereas the second 3 batteries lasted longer than the typical average battery for brand A. So in brand B, we'll do the same thing where we calculated here earlier. The mean of this set of data is going to be 100.5. And so if I wanted to find the deviation from the mean, I'm just going to subtract 100.5 from each one. And then I would continue, I could mark that across each one. But to summarize, once I start subtracting 73 minus 100.5 and 76 minus 100.5, and I'll do this with each one of these, I will get the following deviations from the mean. A negative 27.5, a negative 24.5, a negative 8.5, a negative 6.5, positive 9.5, a positive 16.5, a positive 17.5, and a positive 23.5. And so, again, this is the deviation from the mean itself. And so that's the first step the students are working on in this particular piece. And so if we look at one more, we bring an idea of, what if we had a third brand, brand C batteries? We're asking students in question 8, calculate the mean for the battery life of brand C. So again, just to summarize how that is done, I would take these 5 numbers, the 115 plus the 119 plus the 112 plus the 98 plus the 106, and I'm going to divide that sum by 5, 5 being the number of values that I have in solving for this brand. So when I calculate the mean for that, you would get 110 hours. So what am I going to do with that 110? Well, in question 9, we're asking students to write the deviations from the mean in the empty cells for that particular piece. So up here I would go in, I'm going to do a minus 110, a minus 110, a minus 110, and so forth across. And so when we fill in the difference of each one of those, this would be a positive 5, a positive 9, a positive 2, a negative 12, and a negative 4. And then in our final question for this slide, 10, ignoring the signs are the deviations from the mean generally larger from brand A or brand C? What does your answer agree with your answers from exercise 7? So the students would generally say that the deviations from the mean are generally larger for brand A than what they generally are for anything else, so the answer would be yes. And then in our final piece, our final example for this presentation, is exercises 11 through 15, where we give a histogram of 2 other brands. Brand D, we tested 100 batteries, and in brand E, we tested a similar set of 100 batteries. The results are summarized in this histogram. So this is just more of a discussion than anything else. Like in question 11, estimate, not actually calculate, but estimate the mean battery life for brand D. So if we look at brand D, the data is pretty symmetrical, so we can say the average battery life is somewhere right around this region, where we might call that around 110. And again, that is just an estimate based on what we see. In question 12, we'll say estimate the mean life for brand E. So approximately what do we feel brand E might be? We might say somewhere around 130. If we look at question 13, which of the brands D and E show the greater variability in battery lives? Or do you think the 2 brands are roughly the same in this regard? And so when you look at it, it's kind of the same shape here, roughly the same shape there. So the students might argue that the two brands have roughly the same terms of variability. There's not much of a difference overall between the two brands in variability. Number 14, estimate the largest deviation from the mean of brand D. And so if we look at this, the largest one on here, while it's an estimate, is somewhere right around 143. So if we were to do 143 minus 110, that would end up equaling 33 hours. That would be our largest deviation. Likewise, I know it's not over here because if I did 110 minus 85, so 110 minus 85, that would only be 25. So 33 would be a larger variability difference than 110 to 85. And so the final question here is, what would you consider a typical deviation from the mean of brand D? And so we would say an average variation would be anywhere from 5 to 16 hours would be a good variability for that particular brand before you start to see a lot of differentiation or change. So as a lesson summary, we just want the students to note that for any given value in a data set, the deviation from the mean is the value minus the mean. So written algebraically, this would be x minus the average, or the value minus the average or the mean. So, and then the greater the variability or the greater the spread of the distribution, the greater the deviations from the mean, ignoring the signs of those particular deviations.